So we're going to look at triangle similarity. And so we have two triangles here. These triangles are not congruent. Hopefully that's pretty obvious. You can clearly see triangle XYZ is bigger than triangle ABC. I'm going to go ahead and label up some angles in the triangle. Let's say angle A is 40 degrees and angle C is 60 degrees. And over here in triangle XYZ, angle X also 40 degrees and angle Z also 60 degrees. So we can see, and I'll use a different color, we can see that angle 40, angle A, and angle X are congruent. Angle C and angle Z are congruent. They're both 60 degrees. Even though the triangles aren't the same, they're not the same size, side AB is definitely not as big as side XY, but the angles can still be the same. And so I've got two angles in one triangle, A and C, congruent to two angles in another triangle, X and Z. Turns out we have a theorem that says that the other missing angles, angle B and angle Y, those two would have to be congruent as well. So what I want to do is I just want to go through and prove that really quick to you. So we're not going to do anything super duper formal. But we would be given the fact that angle A and X are congruent and angle C and Z are congruent because that's what we started with. We know, based on the triangle sum theorem, we know that angle A, the measurement of angle A, plus the measurement of angle B, plus the measurement of angle C has to equal 180 degrees. We also know the same is true about triangle XYZ. The measurement of angle X plus the measurement of angle Y plus the measurement of angle Z would also have to equal 180 degrees. Because that's what's true about all triangles. So, since these sums, ABC and XYZ, both add up to 180, what that means is that those two must be the same themselves, right? A, B, and C add up to be the same as X, Y, and Z. And so we could write up an entire equation like that, the measurement of angle A, plus the measurement of angle B, plus the measurement of angle C would have to be equal to the measurement of angle X, plus the measurement of angle Y, plus the measure of angle Z. And since we know that A and X are the same, we could subtract those out. And since we know that C and Z are the same, we can subtract those out. And so what that leaves us with, we're guaranteed that the measurement of angle B would have to be the same as the measurement of angle Y. This is a theorem that we just proved. We didn't fully prove it, but it's close enough. We get the idea. The fact that if two angles of one triangle are congruent to two angles of another triangle, the third angle is always going to be equal as well. We can clearly see that. We know that they have to add up to 180. So in triangle ABC, if angle A is 40 and angle C is 60, angle B would have to be 80 degrees. Likewise, if angle X and angle Z are 40 and 60, angle Y would also have to be 80 degrees. See? Angle B and angle Y are the same measurement. So that theorem is just kind of a makes sense theorem, but it's something that we definitely needed to work through real quick. Now, that doesn't have anything to do with similarity, but the next theorem that we have does. Now, this theorem I'm not going to go through and prove. I just want to state what the theorem is. We have a couple other theorems that are going to go with this as well, but this theorem, I will title it. It's called the angle-angle similarity theorem. This is only for triangles. And it says, if two angles, I'm going to shorthand it, of one triangle are congruent, meaning they're exactly the same, I'll just use the shorthand symbol for congruent, are congruent to two angles of another triangle. We know the third angles would also be the same, but that's not what this theorem is going to tell us. If I have two angles of one triangle congruent to two angles of another triangle, I'm guaranteed the third angles will also be congruent, and then that's going to mean that the triangles are similar. If you go back to an older video, we can see what similarity is, what similar means, and what similar is going to do for us. Remember what similar means. Similar means they're not the same size, but they are the same shape. And they're oriented in such the same way where things match up to be a proportion. So since I know that angle A and angle X are the same, angle C and angle Z are the same, angle B and angle Y have to be the same, these triangles, while not congruent, they're similar. And making sure that everything matches up with similarity, we would say that triangle ABC, remember the similar sign? It's just like a congruent sign without the equal portion. Triangle ABC is similar to triangle XYZ. What that means, again, the angles are all the same. A and X are going to be the same size. B and Y are exactly the same. Angles C and angle Z are exactly the same. And then it means that our sides are proportional. So side AB in the first triangle compared to side XY, if we knew their measurements, and we don't, but if we knew their measurements, we could put them into a proportion. And then we could make that proportion equal to any other proportion of any other matching sides. So AB and XY match up. Side AC matches up with side XZ. And side BC would match up with side YZ. These measurements are all different, but when we put them in a fraction, the fractions are all the same. That's what similarity does for us. So, moving on to an example, we want to find the values of x and y based on these two triangles. So first we have to determine if these triangles are congruent, which they're clearly not. Look at the measurements. One's 28, one's 20, and one's missing in triangle ABC. In triangle DEF, you've got a side of 30, a side of 35, and then another missing side. The sides don't match up, so they can't be congruent. Nothing matches as far as sides are concerned. But as far as angles are concerned, we can clearly see that angle A, 30 degrees, matches angle F, also 30 degrees. And we can clearly see that angle B, 100 degrees, is the same as angle E, 100 degrees. So we can utilize what we already know. If the two angles of triangle ABC match the two angles of triangle DEF, then the third angles that aren't marked, that have no measurement, C and D, have to be the same size. We can figure out what those are if we want to. It's not needed. It turns out they are both 50 degrees because the triangles have to add up to 180. That should be pretty obvious. I'll go ahead and label them as 50, but that's nothing that we needed to figure out. Because the two angles, 100 degrees and 30 degrees, are congruent, we can use that angle similarity from the last slide. If we go back to that slide real quick, there it is again, the fact that if two angles of one triangle are congruent to two angles of another triangle, then the triangles are similar. Okay, and so it's because we have two angles of one triangle matching two angles of another triangle in this slide. Since we have those angles, we can go ahead and say these triangles are similar. And if these triangles are similar, that means that their sides are proportional. We can set up fractions for them. So we have to make sure that we get the right sides. Be very, very careful. So what I always like to do is write up the triangle similarity statement first. And so triangle, the left triangle, you can use any order of the letters you want. I'll just go alphabetical, A, B, C. It does not mean that the other triangle is alphabetical as well. You got to match up the angles. That's the easiest thing to do. So angle A is 30 degrees. We go over to the other triangle. The angle that's 30 degrees is angle F. So F has to go first because F and A match up. Next, in the triangle, we put letter B next in the middle. B is 100 degrees, so we have to have the 100-degree angle. That's angle E, so angle E would go next. And finally, the missing angles, the angles we figured out were 50 degrees, are C and D. Those match up as well. So be very, very careful about automatically going alphabetical order or automatically spelling words. Don't do that. You have to make sure that you're matching everything up. This will allow us to then get our similarity statement, our proportions. The sides then have to match up. And so we can easily, don't even need to look at the picture, we can just look at this statement right here that we just wrote. And using that statement, we can then write up our similarity, our proportions. The fact that AB, the first two letters in this first triangle, have to match up with FE, the first two letters in the second triangle. And that fraction has to be equal to any other two letters we would put together. Say AC, the first and the last letter. That would match up with FD, the first and the last letter. And then finally BC, the second and third letter, would match up with ED, the second and the third letter. Those fractions, all three of them, have to be equal because the triangles are similar. How do we know they're similar? Because their angles match up. If their angles match up, they're automatically similar. That only works for triangles. So when I look at this picture, I can see a couple of sides. I can actually fill in everything from here. So AB is measured out as Y, so we'll put a Y there. FE, if we look at FE, that is 30, so I can put a 30 there. That's going to be equal to AC. AC, according to the picture, is 28. Over FD, we can see that FD is 35. And that's going to be equal to side BC. BC is 20. Over side ED is X. So this is a statement that we can use. We're only going to use two at a time. The one that we're going to use for sure is right here in the middle, that 28 over 35, because we have both measurements. That's perfect, and so we can utilize two different equations. We can ignore the y over 30 just to do x first. So we can take this 28 over 35, but I am going to reduce it. Those are both divisible by 7. And so if I divide top and bottom by 7 and reduce that fraction, that'll leave me to 4/5. That's our scale factor. Remember that from one of the previous videos, the scale factor. And so our scale factor is 4/5. That's going to be equal to 20 over x. And just like we did in the previous video, you can then cross multiply. Let me get rid of the scale factor. We know that that's what that is. And so if I cross multiply, 4 times x is going to be 4x. 5 times 20 is 100. They're equal. Then if I divide by 4, that tells me that x is equal to 25. To get y, we'll do the exact same thing. We'll take that statement of y over 30. That has to be equal to our 28 over 35, which reduced down to 4/5. We can cross multiply just like we did before. 5y is equal to 4 times 30, which is 120. If we divide both sides by 5, y ends up equaling 24. And so there's our two measurements. Pretty straightforward problem. Most of the stuff we're going to do is going to be pretty straightforward. We have to be very, very careful about writing that similarity statement. So we're going to go through one more example here, and then we'll move on to another video where we'll look at more similarity stuff. So let me just split my whiteboard, and we'll take a look at one more example. All right, so poof, just like magic, we have our last example that we're going to look at in this video. Write the similarity statement and the ratios of the sides. So are these triangles similar? Yes, they have to be, according to our angle-angle similarity. 2 angles of one triangle match 2 angles of another triangle, so these 2 triangles definitely similar. They're not necessarily congruent. The angles are, E is congruent to C according to the picture, angle I is congruent to angle A according to the picture, and what that gives us, I'll do that in a different color, what that gives us is angle P would have to be also congruent to angle R. So once we know that the triangles are similar, and so we can write up our similarity statement. This is not the similarity statement. I'm just going to state the fact that the angles all match up. So again, angle E is congruent to angle C. Angle I is congruent to angle A. And then angle P, by default, has to be, by theorem, has to be congruent to angle R. Knowing that, whether we write that out or not, is good, because then that can get us the triangle statement. Notice they could spell words. I don't have to spell words. The similarity statement based on these, if we go EIP, that triangle would have to be similar, don't want to go congruent, almost did congruent, similar to triangle CAR because of the angles that match up. And then the proportion statement, once we've got the triangle statement, the proportion statement's really, really easy. Just grab any 2 letters from the first triangle, EI, grab the matching 2 letters of the other triangle, CA. Repeat that process, grab 2 other letters, EP, grab the matching letters, CR. Finally, the 2 letters you haven't used yet, I'm going to go weird, I'm going to go PI, no problem. Since I went PI, I have to go RA. There's the similarity statement. Our next video, we'll look at some more examples, and we will get some homework in the next video.